So right now we are going to basically solve a problem on Spearman's rank correlation, but only in the case of repeated ranks. Since it is slightly difficult, we are going to do only the case of repeated rank. The case where ranks are not repeated is very easy. You just have to take rank X or rank Y, then take D, and then take D square, and then use the formula. Now this is the case of basically the repeated rank. Now in the repeated rank, what is happening is the formula is 1 minus 6 into summation of d square plus summation of m into m square minus 1 upon 12 upon n into n square minus 1. And m is the number of times the rank is repeated. We all know what is d. D is the difference in rank. N is the number of observations. M is the number of times the rank is repeated. Now we'll solve a problem of calculating the Spearman's rank correlation, but this is a case of repeated rank. You can see here that the rank 3 is repeated twice, rank 5 is repeated twice. Even in the case of rank Y, 1 is repeated thrice. So we will learn how to solve. The solution is simple. You take the column rank X as it is, and then you take rank Y as it is, these two columns. But while writing the ranks, you have to be careful. You have to write only those ranks which are not having any problem, as in those ranks which are not repeated. So if you see, look at series X, the rank 1 is not repeated, so you write as it is. Again, if you see in series X, the rank 2 is not repeated, you write it as it is. Since the rank 3 is repeated, don't write it, leave a gap for it, wherever there is 3, leave a gap. Even if you see here, the rank 5 is also repeated, so leave a gap. But rank 7, if you see, does not have any problem, so it will come here. Okay, it will come here. Now what we'll do in place of these gaps, we'll have to fill all these gaps now. Idea is, here there was originally, if you see, there was rank 3. This had to be occupied by rank 3. But if you observe here that 3 is getting repeated. So what you have to do is basically you have to take this rank, and if you observe that in your series X, rank 1 is there, rank 2 is there, 3 is there, but there is no 4. So that 4 is the missing rank. So what you have to do, you have to find the average, 3, 4. Basically it's a repeated rank, repeat 1, repeated rank, and this is the missing one, the rank that is missing. If you see in the series X, there is no 4, so this is missing. Find the average, 7 upon 2, the average is 3.5. So what will happen is, each rank will be given, instead of 3, we will be putting 3.5 here. So this box is filled by 3.5. So another case, here also the box is filled by 3.5. Same thing will do for other repeated rank. The rank is 5, and if you observe that the missing rank in this case is 6, so it is 5 plus 6 upon 2, which is 11 upon 2, which is 5.5. So in both these places we will put 5.5. Fine. Now we proceed with do the similar thing to the series Y that is there. We do the similar things to series Y. If you observe in series Y, 1 is a problem. This rank 1 is also a problem. So what I'll do, for the moment, I'll just keep a gap. For the moment, I'll just keep a gap at all these ones. Now what is happening for us? 4 is not a problem because 4 is not repeated. 7 is not a problem. 6 is not a problem. 5 is not a problem. Problem is this one. Now you have to do a similar kind of thing which we have done here to this ranking one, but in a slightly different way. What you have to do is, now in this case, the repeated rank is 1. Who are the missing rank? If you observe here, there is 1, but there is no 2, there is no 3, there is directly 4. So your missing ranks in this case are 2 and 3. So these are your missing ones. And you have to take the average. Now when you take the average, since these were two numbers, we divided by 2. Now these are 3 numbers. You have to divide by 3. So 3, 4, 5, 6 upon 3, which is 2. So all these blank spaces will be filled by 2. Blank spaces are filled by 2. Now the rest part is obvious. Rest part is obvious. You have to just do D like how we earlier did in the previous problem and find D square. Now D is what? Rank X minus rank Y. So it's 1 minus 2, which is minus 1. 2 minus 2 is 0. 3.5 minus 4 is minus 0.5. 5.5 minus 7 is minus 1.5. 7 minus 6 is 1. 3.5 minus 5 is minus 1.5. And this is 5.5 minus 2 is 5.5 minus 2 is 3.5. Now you have to find D square. D square, what you do? You square all these entries. Minus 1 square is 1, 0 square is 0, minus 0.5 square is 0.25, minus 1 square is 2.25, 1 square is 1, this is minus 1.5 square is 2.25, and this 3.5 square is 12.25. This D square you can easily find. Now we will have to do like in previous case, find sigma D square. So sigma D square is simple. You basically add all these vertically. You take a calculator, add all these numbers and see what is the answer. So it should come to 1, 1.5, 1.25, so 3, 3.5, 4.5, 4.5, and then it should be 12.5. This should be 14.5, so it should be 19. It should be 19. You add vertically this 1, 0.25, you will get 2.5, 3.5, 4.5, and then 4.5, I think 12.5, 14.5. So it's 19, correct. Summation of D square is 19. Now, if you observe carefully in this formula, we have 1 is there, 1 is known, 6 is known. Now we have got summation of D square is known. Our summation of D square is 19. N is anyways the number of observations. So we have 1, 2, 3, 4, 5, 6, 7. So in our case, N is 7. So this is also known. But the problem is this we don't know. This we don't know. So basically what we'll do is our aim right now is to find this summation of m into m square minus 1. There is a way to find this. Observe carefully. Now our aim is to find the m part. See how we do the m part. Basically, you take repeated rank. You draw a table, small table. You take m. You do m square minus 1. And then you do m into m square minus 1 upon 12. These are the 4 things that you are going to do. These 4 columns you are going to draw. Now, your repeated x column will contain the ranks which are repeated. Now, if you observe in your series x, which is given here, the rank 3 is repeated. Rank 3, if you observe here, is repeated twice. And in series x, rank 5 is also repeated twice. So see how are we going to write down? We are going to say in series X, it is rank 3 that is repeated. In series X, it is rank 5 that is repeated. Now, what is M? M is the number of times the rank is repeated. Number of times rank is repeated. Now, if you observe in series X, the rank 3 is repeated twice. And in series X, the rank 5 is also repeated twice. So M is 2. Now you do M square minus 1 is 2 square minus 1, which is 4 minus 1, which is 3. And then you do M into M square minus 1 upon 12. That is 2 into 3 upon 12, which is 6 upon 12, which is 0.5. Same thing will happen for the other rank. This will be 3 and this will come down to 0.5. Also, we are not done with this M calculation because in series Y, if you observe, the rank 1 is also repeated. If you observe here in series, if you observe in series Y, the rank 1 is also repeated. See, here this rank is 1 is also repeated. So, but the thing is, this rank is repeated thrice. So M is 3. And then what you do? You do M square minus 1, which is 3 square minus 1, which is 9 minus 1, which is 8. And then you do M into M square minus 1. See, this is M, this is M square minus 1. So you multiply both of them, you divide by 12. 8 3 is 24 upon 12, which is 2. Now you have to, if you look at your formula carefully, you want what? You want the sigma summation M into M square minus 1 upon 12. So what we do? We find sigma M into M square minus 1 upon 12. And how we find sigma? We just add all these entries. So we basically add 0.5 with 0.5 and then 2. So 2 plus 0.5 with 0.5 will come down to 3. So this is 3. So this is done. Now we have everything to use the formula. So we directly use the formula. Our formula is capital R is equal to 1 minus 6 into sigma d square plus sigma m into m square minus 1 upon 12 and whole upon n into n square minus 1. Now we have this is 1 minus 6 into sigma summation of d square. If you observe carefully, which we found here, summation of d square is 19. See, summation of d square was found here 19, and at the same time have a proper look that summation of the m into m square part term is 3. So this is the first term is 19, second part is 3. N is number of observations. So if you look carefully in our question, we are given ranks of 7 items 1, 2, 3, 4, 5, 6, 7. So what will happen is Rn will be 7. So here 7 will come into 7 square minus 1. So this is 1 minus 6 into 19 plus 3 is 22 upon 7 into 49 minus 1. So this will be 1 minus 132. 26, I think 22 into 6 is 132 and 7 into 48. So 1 minus 132, 7 into 48, if you realize it is 336, you multiply and say it should be 336. And then we divide 132 by 336. We divide 132 divided by 336. You get the answer as 0.39. So this answer is 1 minus 0.39, and this when you subtract, you get it as 0.61. This is how you get your answer. Such problems.